This video goes over adding and subtracting rational expressions. So adding and subtracting rational expressions is the same as adding and subtracting any type of fraction. You just need to find a common denominator. So we can find a common denominator always by multiplying the two or three denominators together. It won't always give you the lowest common denominator. It will always give you the common denominator. So in our first example, our common denominator is 21. So I'm going to multiply the left-hand side by 3, and then the right-hand fraction by 7, which gives me 2 equivalent fractions. And then I can add my numerators together and leave the denominator the same. In my next one, I've got x's on the top and numbers on the bottom. I find my common denominator in the same way by multiplying the two denominators together, which also happens to give me the lowest common denominator. My left-hand fraction I'm going to multiply by 7, and my right-hand fraction I'm going to multiply by 5. My two new equivalent fractions are 7x over 35 and 5x over 35. Just like before, I'm going to subtract the numerators because that's the operation that's in between. So I end up with 2x over 35. In my next example, now I have a variable on the bottom. So I'm going to find my common denominator in the same way by multiplying the y and the 4 together, which gives me 4y. My left-hand fraction, I'm going to multiply the top and the bottom by 4 to change my denominator to 4y. And I'm going to multiply my right-hand fraction by y, top and bottom, to change my denominator to be 4y. That means my two new equivalent fractions are 4 over 4y and y over 4y. In order to add those two together, I'm going to add my numerators, and I'm going to keep the denominator the same. The only other thing I have to add in now is that because I have a y on the bottom, that means that if I substitute in y equals 0, my denominator is going to equal 0. So here I have a restriction that y can't equal 0. Let's take a look at the last one, where we've got a y on the denominator of the first fraction and a y squared on the denominator of the second fraction. Now, to find my common denominator, I could just multiply them together to give me y cubed, which would work. But I can also notice that if I just multiply my first fraction by y, my denominator is going to end up being y squared on the first fraction, which is common to the denominator of my second fraction. So if I change the first fraction into y over y squared, I can add that to 1 over y squared because the denominator is common. Now I've got y plus 1 on the top, y squared on the bottom, and just like before, I've got the restriction that y can't equal 0. Let's try a couple more examples. Here I've got p as my first denominator, and I've got 4p as my second denominator. Now I could multiply them together, and I would get 4p squared, which would work. I'd have to reduce at the end. What I notice here is that if I could make my first denominator 4p, that would be equivalent to my second fraction. So I'm going to use a common denominator of 4p instead, which I can get to just by multiplying that first fraction by 4. So my first two equivalent fractions are 8 over 4p minus 5 over 4p. Now my denominators are common, so I can subtract the numerators, and then I've got a variable on the bottom, so I can state my restriction. If p is equal to 0, that's the only value that's going to make the denominator equal to 0, which is going to give me a restriction. Example F here is a little bit more exciting because I've got more than one variable on the bottom. So I'm going to look at my common denominators. The first thing I'm going to look at is how can I make the x's the same. The exponent on my second denominator is 5, and the exponent on my first denominator is 2. So I know that if I multiplied my first fraction by x cubed, that would change my exponent on the x in the denominator to an x5. And then I can see that if I multiply, I'm going to look at the y's next. So I can see that I've got a 3, y to the 3 in the first denominator and a y to the 1 in the second denominator. So I can see that if I multiplied my second fraction by y squared, let's write that in, that would change the exponents on my y's to be the same. So that means that my common denominator is really x to the 5, so my highest x exponent out of the two denominators, y3, my highest y exponent out of the two denominators. So my first fraction, I'm multiplying the top and the bottom by x cubed to change that exponent on the x. And my second fraction, I'm changing my exponent on the y by multiplying the top and the bottom by y squared. So I'm going to be left with 7x cubed over x5, y3. And in my second fraction, I'm going to be left with 3y squared over x5, y3. Now my denominators are common, so I can add my numerators together. And those terms aren't like, and there's nothing in common between all three terms, 2 on the top and 1 on the bottom, that I can cancel out. So I'm finished, except for the restrictions. I have an x and a y on the bottom. The only values that are going to make that term equal to 0 is if x is equal to 0 or y is equal to 0. So we say that those ones are restrictions and that the variables can't take on those values in the expressions. Okay. Example G, here I've got 3 fractions that I'm looking at. I've got a squared, b squared, and a squared. So it looks like my highest exponent on the a is a squared. So I need to multiply everything so that it has an a squared on the bottom. So that means my second fraction doesn't have any a's. So I'd multiply the top and the bottom by a squared. The other variable that I have is a b squared, which is the highest exponent. So I need everything to have a b squared. I'm going to multiply the last fraction by b squared and the first fraction by b squared. So that's taking care of all my variables. Now I have to look at the numbers. So I have a 2 and a 4 and a 1. So I'm going to make sure that everything has the number 4 on the bottom so that my fractions are equivalent, my denominators are all common. So that means that I also need to multiply my first fraction by 2, and I need to multiply my last fraction by 4. So let's put those numbers in there. So my new first equivalent fraction would be 10b squared over 4a squared b squared. And I should just have up here, this should be a 2. So let's just change that so it matches because I'm trying to get to the number 4. There we go. Okay. My second one is 7a squared over 4a squared b squared. And then my last one is 24b squared over 4a squared b squared. You can always check to make sure you've multiplied correctly by reducing each of these expressions, and you should get back to the original question. Okay, so now my denominator is the same. So I can add or subtract the numerators together depending on what the sign says. So I've got 10b squared plus 7a squared minus 24b squared. Collecting like terms, I'm going to end up with 7a squared. 10 minus 24 would be minus 14b squared. All over a squared, b squared here. I am going to keep going because I can factor a 7 out from the top. And I'm going to get a squared minus 2b squared all over 4a squared, b squared. Okay. You could go a little bit further and factor this second part as a difference of squares. That is not going to be all that helpful for us in this case. So I'm just going to leave it as is, and I'm going to state my two restrictions. So a can't equal 0 and b can't equal 0. Okay. Our last example here. Now we've got expressions on the top that are a little bit more complicated. So I'm still looking for a common denominator between 7 and x. So my common denominator I can see is just 7x. So I just multiply those two together. Also happens to be the lowest. So in order to change the denominator of my first fraction, I'm going to have to multiply top and bottom by x. In order to change the denominator of my second fraction, I'm going to have to multiply the top and the bottom by 7. So my first fraction, I'm going to get x times x minus 3 all over 7x. And then here I'm going to take away 7 times x squared plus 5x minus 1 all over 7x. Now the tricky part when you've got more than one term on top is that whatever you multiply by has to apply to every term inside the brackets. So here when I expand from my first fraction, I'm going to get x squared minus 3. And then I'm taking away 7x squared plus 35x minus 7 all over 7x. So this minus sign applies to all three of those terms from that second bracket. So I'm going to write it out one more time, making sure I flip all those signs on that second term. And now I can collect like terms. So I've got minus 6x squared. This should be a 3x here. Then I've got minus 3x minus 35x is minus 38x. And then I've got a 7 at the end. And then I've got a couple options here. One is I have a negative sign at the beginning on the top. I could factor that out, but I don't have to. And then I'm going to check and see if that trinomial factors. And I can't, this is as simple as I can go, so I'm going to stop there. And then I'm going to state my restrictions. I only have an x on the bottom, so I'm going to say that x can't equal 0. And those are examples of adding and subtracting rational expressions with one term in the denominator.